In this video, we are going to dive deeper into conjugates of surds. In a previous video, I mentioned it in passing, but I want to take a little more time to explain exactly how you can find the conjugate of any surd expression. We have 5 examples to work with, and we have this graph on the right-hand side. So I'm going to show you the logic behind finding the conjugate of surds. Our first example is root 5. And on our graph, root 5 is located here. Now, to find the conjugate of any surd, all you have to do is imagine this graph that I've drawn and then draw a straight line to the opposite side. So, for root 5, which is here, the conjugate of the surd will be the straight line on the opposite side, which is negative root 5. For our second example, we have root 5 plus 3. Now, I have stipulated this point by the green dot here. So if we draw a straight line from that green dot, we can either go to the blue dot on the left or we can go to the yellow dot on the bottom. The best thing for us to do is to go to the yellow dot because it is closer. So that leaves our answer as root 5 minus 3. Our third example is root 5 minus 3. Now, our intuition would be correct if we already say that the conjugate of root 5 minus 3 is root 5 plus 3, because conjugates are interchangeable. Again, if we look at it in our graph, root 5 minus 3 will be at the yellow dot. And if we draw a straight line in the opposite direction, we will get to root 5 plus 3. Number 4 and 5 are a little bit tricky because we're starting on the negative side of the surd. And I'll show you 2 ways to handle this. For example 4, we have negative root 5 plus 3, and that's designated by the blue dot. Technically, based on the rules that I have just shown you, in order to get the conjugate, we would have to go to the purple dot, right? Because we're taking a straight line from the blue dot and we're taking the shorter line. So technically, we will have negative root 5 minus 3. And finally, for example 5, we have negative root 5 minus 3, and that's designated by the purple dot. And if we're taking the shorter distance, we will land at the blue dot, which is negative root 5 plus 3. We could stop here, but I want to make something clear. Generally, when we're dealing with conjugates of surds, it's in order to rationalize the denominators. And in the general context, the rule is that you keep the first term as it is, and then you change the sign of the second term. But in order for things to be normalized across board, what we usually do is that we usually make sure that the first term is the integer term and the second term is the surd term. That means that, for example 4 and 5, we can write them as 3 minus root 5 and minus 3 minus root 5, because we want to keep the integer term as our first term and then the surd term as our second term. Let's make it 4b and 5b. So in this case, based on the rule that I just mentioned, keeping the first term the same and changing the sign of the second term, the conjugate of 4b, which is 3 minus root 5, becomes 3 plus root 5. And 3 plus root 5 is designated by the green dot. And then for example 5b, we will then have negative 3 plus root 5, which is the yellow dot. So in actuality, instead of the blue dot moving to the purple and the purple moving to the blue, we ended up having the blue dot moving to the green and the purple moving to the yellow. I hope I haven't confused you too much. The point is, when you're dealing with conjugates of surds, make sure that you arrange your surd in such a way that the integer term is the first term and the surd term is the second term. After you do that, you can now apply the general rule of changing the sign of the second term. We'll close it off with an example of how to apply these principles. The question says, simplify 7 plus root 5 all over root 5 minus 1. Solution. The first thing to do is that we need to say, what is the conjugate of our denominator? Because all that we've learned is to be able to apply it to rationalizing denominators. Remember I said that you should keep the integer term as the first term and the third term as the second. So we can rewrite our expression as 7 plus root 5 all over minus 1 plus root 5. And the conjugate of the denominator will then be minus 1 minus root 5. So at this point, we can easily rationalize our fraction. What we'll have is 7 plus root 5 over the original expression, which I want to keep in its original form, root 5 minus 1. And then we'll multiply both the numerator and the denominator by the conjugate, which would be minus 1 minus root 5 over minus 1 minus root 5. That would give us 7 plus root 5 minus 1 minus root 5 all over root 5 minus 1 multiplied by minus 1 minus root 5. At this point, all we have left to do is expand our brackets in order to simplify. Follow along with me as I do it. So we'll have minus 7 root 5 minus root 5 minus root 25 all over minus root 5 minus root 25 plus 1 plus root 5. As usual, minus root 5 and plus root 5 will cancel each other out. And since we know that root 25 is 5, we'll effect that on the next line. So what we'll have is minus 7 minus 5 minus 7 root 5 minus root 5 all over minus 5 plus 1. So what I did was I collected the like terms. I put the integer terms together and the surd terms together, so it's just easier to work with. And then what we'll have is minus 12 minus 8 root 5 all over minus 4. At this point, we can factorize. And one easy factor that we can see is minus 4. So that would be, if we bring out the minus 4, we'll have 3 plus 2 root 5 all over minus 4. And when the denominator and the numerator cancel each other out, our final answer would be 3 plus 2 root 5. Congratulations. I hope you enjoyed going through this video with me. Thank you for watching this video. I hope you enjoyed it. If you have any questions or you need direct math tutoring, feel free to email us at durotutors@gmail.com. Please like this video, share, and subscribe. I'll see you in the next video. And until then, keep Doroing.